What's going on, you guys? So today we're doing power of 3. So we're given an integer. We want to write a function to determine if it is the power of 3. So for example, 3 raised to the power of 3 equals 27. 3 raised to no power equals 0, so this is false. 3 squared is 9, so true. And 45 is not a power of 3, so that would return false. So let's try and come up with a naive solution first, and then we'll see if we can do it without a loop or recursion. So let's do some examples here. So let's think about 27. So how do we know this is a power of 3? Well, 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. Okay. Let's do another one. So 0 divided by 3 is 0. Okay. 9. So 9 divided by 3 equals 3. 3 divided by 3 equals 1. And 45. 45 divided by 3 equals 15. 15 divided by 3 equals 5. And 5 divided by 3 equals 1 2/3. 1.67. Okay. So when we keep dividing by 3 and the last value, the last remainder is 1. That could be a rule, right? So if we keep dividing by 3 while the remainder is 0, right? The remainder here is 0. The remainder here is 0. And then 1 divided by 3 is remainder 1. So we'll keep going until we get a remainder that is not 0. And then we'll compare that value. So if the last remainder is 1, return true. Otherwise, we're going to return false. Like, for example, 0 will return false. So 5 remainder 3. 5 remainder 3. Sorry. That is going to equal, what is that? Is that 2? Yeah. Okay, so that will not equal 1, so that will return false. Okay, so here's the pseudocode. Just return, so we'll, while n is greater than 1, while the remainder of n divided by 3 is 0, and we're going to divide n by 3. Continuously divide n by 3 until we get that final remainder. Okay, and then we'll return n equals 1. If it's not 1, then it's, for example, 45 is an example where it's not 1. 0, it's not 1. And also we have to think about what happens if we get 0 or negative numbers. So 3, you cannot raise 3 to any number and make it negative. So if it's a negative number, we have to return false. If it's 0, we need to return false. So we'll wrap this all in if n is greater than. What do we do if we get 1? If we get 1, let's think about this. So 1 is not, 3 to the 0. 3 to the 0 is 1. Okay, so 1, no problem. Okay, so if n is greater than 1 or greater than 0, yeah, if n is greater than 0. And negative numbers will return false. 0 will return false. 1 will return true. Yeah, that's what we want. Okay, and let's think about space and time complexity. So we're going to be dividing by 3 every time. So it's, so how do we, so if something is halving each time, that's going to be a log of n. Okay, so let's think about this. So n equals 1/2 n equals n over 2. That is log n runtime. And why is that? So log n is 2 to the x equals n. Two or 10 to the x equals n. Two to the what equals 1/2 n. 2 to the y equals n over 2. Okay, so let's do, we're getting in the math here. Let's see. Okay. So if we take the log of both sides, we're going to get log 2, x times log 2 equals log n. X equals log n over log 2. And in this one, if we're looking at 1/2 n, let's do the log again. So y equals n over 2. And how do you, okay, let's think about this. So y, let's copy this. Y equals log n over 2. Okay. Interesting. So can we learn anything from this? If we have n, our exponent is halved. Right? Because n represents, is that right? Oh, I'm getting this wrong. So, shoot. So it's some kind of a log. So it's not exactly, so if anyone can help on the runtime on this one, let me know. But it's something like log n. So if it was halving every time, it would be log n. This time it's like a third every time, so it's even faster than log n. So log n is like, it's faster than log n, time complexity. And space, it's gonna be just O of 1. We're not storing, we're only doing one call, it's not a recursive call, and we're storing the, we'll store one variable, an integer value. So it's just O of 1 space complexity and something like log n time complexity. Go ahead and let me know in the comments if you can, how else you would think about time complexity for this one. Okay, let's turn our pseudocode into Kotlin. So if, what do we say, n is greater than 0, we'll keep while n, oh, and we want to do, so Kotlin, n is a read-only variable, so we need a write variable. So we'll call it remainder, set it equal to n. Let's use remainder. While remainder modulus 3 is 0, remainder divide equals by 3. Okay, and then we'll return remainder is equal to 1. All right. Okay, there you go, guys. So that's with a loop. So if we were not going to use a loop, let's think about it. So, okay. And do a little math here. Okay, so 3 to the x equals n. So we can take the log of both sides. So x times log 3. Oh boy. All right, so we're going to go back to the, that's getting a little, okay, so, okay, so, let's do it here. Okay, so 3 to the, sorry. Okay. 3 to the x equals n, right? So we can take the log of both sides. So we can say x times log 3 equals log n. Okay? And x equals log n divided by log 3. So that's going to be our exponent. If our exponent, we know that if this is an integer, right? So 0, 1, 2, 3, 4, so on and so forth, then this is a power of 3. So we can check if this is an integer or not. And if it is, we'll return true. If not, we'll return false. So that's the thinking about not using a loop or recursion to solve this problem. So how are we going to do that? Okay, let's think about some pseudocode. Okay. Okay, so say exponent equals log, what do we say? Log n over log 3. And we'll return is int exponent. So we'll make a function to figure out how is this an integer or not. And then what's our is int going to look like? Fun is int. So this will take x, which is a double, and we'll return a Boolean. Okay, so we're going to convert, so n is an integer, we're going to convert it to a double. Okay. Let's think. And the reason we're doing doubles here is because the log function in Kotlin, it requires a double. Our base and our x have to be either doubles or floats. So that's why we're converting there. Okay. So how are we going to do this function? So if we round x, and we take the difference with x, so if we have like 2.9 and we round that to 3, so 3 minus 2.9, it's going to be a very small number. So if that number is very small, then we should return true. So and how small? It depends on how big. So n is an integer. So what's the max integer value? Max integer. Java. It's the same for Kotlin. So the max integer is 20, this thing. So our number of significant digits depends on this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're not going to get an 11-digit integer, for example. Okay. So we can do 10 significant digits here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And we have to do the absolute value, because if this is like 1.01 and we round this, then this will be a negative number. So we'll just wrap this in the absolute value. Okay, so let's try that. So we'll say, oops. Okay. Okay, just cleaning this up. Oh, there we go. Okay. All right. So log, it also log Kotlin. So there's two variables, a x and a base. X and base. Okay. So we'll just do base 10. 10, and it has to be, the base is a double. So 3.0. 10.0. Okay. All right. And let's think about this. Is this all we need? Oh, we need to import these functions. So import Kotlin dot math dot log abs and round. So round, just it rounds to the nearest integer. Okay. Let's see if that works. Uh-oh. What's the problem here? Oh, gotta call that function. Okay. Okay, there you go, guys. So it's a little bit slower. I would imagine all these different function calls, I guess they add a little bit of time. It's a little bit slower than the for loop. Let's run it again. Yeah, so a little bit slower than the for loop, but here's how you would do it without a loop. All right, guys, that has been multiple of 3, power of 3. Stay tuned for the next one.